right. Welcome everyone to Terraform providers using AWS CloudFormation custom resources. Before I start, quick show of hands. Who has experience with CloudFormation? Okay, almost everyone. And with Terraform? Okay. And who likes the one above the other? Doesn't matter which one, but do you have a preference on one of those? Okay, it depends. Correct answer, yeah. Hopefully after this talk, you will love both of the applications because we are using them quite a lot. Before we start, quick introduction. My name is Martijn van Dongen. I come from the Netherlands, Amsterdam. I'm a cloud evangelist working for Schubert Philips. Probably you never heard of our company. We're just with 400 people in the Netherlands with basically local customers. But the customers we also have are becoming more the global customers. So one of them will be tomorrow in the keynote, so I encourage you to visit the keynote. We are basically a mission-critical company, so we aim for 100% with everything. So first place, 100% customer satisfaction, but also 100% automation, etc. So that sets the stage for this talk as well. Next to my day-to-day job at Schubert Philips, I'm also a cloud evangelist, a community hero, and that basically because I organize a lot of meetups in the Netherlands. So they're a little bit smaller than this room, about 80 people. So I'm kind of a little bit nervous right now, although we also did a big event a couple of weeks back, Community Day with 500 people, and Werner Vogels as the keynote speaker. So we're really proud on, well, that big event. Next to me is Sohan. Can you introduce yourself?
Yeah, of course. Hi, my name is Sohan Maheshwar. I'm a senior dev advocate with AWS based in the Netherlands, where I work with Martijn on community events. And yeah, this is my 5th re:Invent, so I'm super excited to be here. Martijn, why don't you take it away?
Cool. So our talk is based on a true story, and actually based on 2 true stories. The first one is one of our customers. It's a big lease car company service, and they have over 1,000 engineers that, of course, have to automate everything. And when they were automating everything, they discovered that not all the applications were able to be automated. So we had to use some kind of technology to also automate the parts that are not native in AWS, for example. And if we let them go, so just develop it on their own, you get all variations of implementations, and that's what we would like to avoid. That's what you can see here. So one team is using CloudFormation, so they built their own custom resource provider or their own tooling to provision those custom resources. The Terraform implementation is also different. They use different tools, different coding languages, so also a different implementation. And for CDK and for all the other infrastructure as code frameworks, same thing happens. So what we were looking for was actually this, where we can have a common implementation that all these popular applications, cloud infrastructure configuration languages can work with. And we found it using CloudFormation, that I will show you in this presentation. The other example came in a little bit later, so just a few weeks ago. I found out that in one of our customer teams, they were working with a lot of breweries around the globe, and they use IoT Greengrass, the green icon. And to provision your IoT Greengrass, you can use Terraform, you can use CloudFormation. And with Terraform, if you provision something to AWS like EC2, it works great. If you try to do it with Terraform to Greengrass, it's not that optimal. When you use CloudFormation, it's close to optimal, but there are still some things that we would like to do that was not natively supported in CloudFormation. So we resolved the specific use cases using an AWS Lambda.
Right. So essentially, Martijn spoke about 2 customers. Now, we can't show the demo of those products, of course. So we want you to imagine like a legacy application. I'm a kid of the 90s. So this is how most websites looked back then. So just think of a legacy application. Maybe it needs a little more Comic Sans, I don't know. But So this is just a visual aid, all right? And we're going to talk to you about how you can use CloudFormation, specifically custom resources in CloudFormation. Now, I know everyone here knows what CloudFormation is, but this talk is also being recorded, so there may be people who might not know. So just a very, very quick refresher on CloudFormation. It lets you model, provision, and manage AWS and third-party resources using infrastructure as code. It's the OG infrastructure as code service, as I'd like to call it. Don't quote me on that outside of this room, I guess. But essentially, you code in YAML or JSON directly, or you can use sample templates. You can upload these templates to an S3 bucket or to the CloudFormation resource itself. When you deploy these templates, it creates a stack. Right? It creates a stack of the resources that you've deployed, and those stacks and resources are provisioned as your running environment. This way, you've represented your entire infrastructure as code. So this is repeatable, it's completely automated, you can roll back, yada, yada, yada. What we want to really focus on is this one feature of CloudFormation called custom resources. We think that this is a pretty powerful feature of CloudFormation, and essentially it allows you to write custom provisioning logic within a CloudFormation template. Now there are two things you can specifically do. One is there are AWS services that aren't supported in CloudFormation, which you could reference using a custom resource. Or you could also reference a third-party resource using custom resources. When you're writing CloudFormation code, this is typically what it looks like. Simplest example, you have a type which is an EC2 instance. So there is a particular syntax that you have to follow. Right? So you say type is equal to AWS EC2 instance, and then the properties below sort of describe that EC2 instance. And that's how when you deploy this CloudFormation template, this EC2 instance is up and running in the cloud. For a custom resource, the syntax is quite similar. The difference is the type is custom, followed by a name that you can give, and we are going to call it a unicorn tracker. It's a simple application that just allows you to add and delete unicorns, which you will see very soon. And essentially, in the properties, you have to mention something called a service token. Right? So how custom resources works is first, there is something called a custom resource provider. Right? So someone who's written a template that provides for the custom resource. Then, of course, there is the custom resource itself, which is what we'll be doing. And third, CloudFormation actually runs the two. Now, this provider and the custom resource sort of talk to each other using this thing called a service token. The service token could either be a Lambda function or it could be an SNS topic. So essentially, when that custom resource, that template starts, this Lambda function or the SNS topic is alerted, and things happen behind the scenes, which I will describe to you in the next slide. This is our implementation for custom resources. So essentially, you have an author who's written a custom resource provider in a CloudFormation template. Again, there is a slight difference in the syntax. There is a custom resource provider and a custom resource itself. Both of them are written as CloudFormation templates. The logic of this custom resource is authored in that Lambda function. So when you deploy the CloudFormation stack, it speaks to the Lambda function, which gets the provider and the custom resources. What happens behind the scenes is that this Lambda actually writes to a pre-signed S3 bucket. Right? So there's a pre-signed URL with an S3 bucket, and the results of the deployment are sent to that S3 bucket. CloudFormation verifies looking at that S3 bucket, and then goes ahead and creates all of your resources. Right? So all of that is happening behind the scenes. We as builders, or you as builders, we don't have to worry about any of this. Right? You have to focus only on your custom resources and the custom resource provider. So what sort of code do you actually write in a Lambda function for a custom resource? Well, it is typical CRUD operations, right? Create, read, update, and delete. So this is sample code of how your Lambda function would look like. Right? Again, goes without saying, but you could write this in any language supported by Lambda. If you want, you could also do that in a Docker container. For this demo, we have written it in Python. So as you can see, there is an API, which is the API our ugly legacy application uses behind the scenes. And you can see we've written a create function, which just creates a unicorn. And we've written a delete function, which just deletes a unicorn, right? Super simple. Our CloudFormation code looks a little something like this. You can see a Lambda layer there. That layer, if you're not familiar with Lambda layers, it's something that you can use within your Lambda functions if your Lambda function has things like dependencies. So for instance, if you have some Python libraries that you want to have as part of your Lambda function, you can put that in a Lambda layer, which can be shared. Then, of course, we describe the Lambda function itself, and you see all of that. And right at the bottom is the endpoint, which again, I said, is the API endpoint for our legacy application. So let's actually take a look at how all of this end-to-end will look in a demo. We have, of course, pre-recorded it because waiting for CloudFormation to, thing isn't the most fun demo, so we'll go through it rather quickly. All of this code is available on GitHub, and we will be sharing the link at the end, right? So all of it's there, so don't worry about that. Right. So essentially, we haven't spoken yet about Terraform, but the room seems very familiar. We're going to use just 2 Terraform commands for this part of the demo. Terraform init initializes Terraform. Terraform apply goes ahead and creates cloud resources, right? That's pretty much it. So hopefully you can see the screen at the back, but we are essentially initializing Terraform, and we are going to initialize our legacy application. Shout out to Dennis and a couple of folks here in the front row who helped us write that application. And this is going ahead and creating, I'm just going to pause that there. Yeah, this has created resources in the cloud, and it's created an endpoint, which is the API gateway URL, right? This is the endpoint for our legacy app. We will be using this in the rest of our demo. Again, this API is an open API, as you will see right now, but if you want to add authorization or anything to it, you can do that via open API gateway. For the purposes of the demo, this is right now an open API. Right? As you can see, there's nothing in the API in the backend right now, no items, so we will be adding it using our Lambda function very soon. Okay, so yeah. So now we're going to create the custom provider itself using this particular CloudFormation template. Right? And as you can see in this template, this is the code that I showed you earlier. There is a Lambda layer, and there is an endpoint right at the bottom. So we're going to deploy this CloudFormation template very quickly. You can see the resources that are mentioned in this particular CloudFormation template. And this is written in Python 3.9, but like I said, you can write it in any language that Lambda supports. Right? So what we're going to do now is also very quickly look at the Lambda function itself. Right? The one thing I want you to look at is line number 3. Right? That's the hidden hero of this entire demo, which we didn't speak about in the slides, but it says from CR helper. Right? So that is short for custom resource helper. It's an open source module developed by AWS itself. It's very, very helpful when you want to reroute requests from custom resources, because it takes care of the mapping. So when CloudFormation sends an event to your Lambda function, this takes care of the mapping automatically, right? Otherwise, you have to do all of that manually. So as you can see in the code itself, you see @helper.create, @helper.read, @helper.delete. This is CR helper doing all of that work for you. So if you're using custom resources, I highly recommend you check out this particular module. The code in itself is trivial. All it does is add and delete unicorns, so don't worry too much about it. You can see a backend API mentioned there, and the rest is typical CRUD code. We haven't written the update function. That's an exercise for the audience, or we just ran out of time. One of the two, you'll decide. Yeah, and as you can see, you can delete a unicorn as well. So what we're going to do now is we have the CloudFormation template, we have the Lambda code. So yeah, let's just deploy it. So to deploy it first, we need an S3 bucket, and I'm going to create an S3 bucket which is imaginatively named some random bucket 1, 2, 3, 4. Honestly, it was a miracle that this worked, right? I was convinced that someone's taken that name before. Apparently not. So yeah. This is the endpoint we got earlier from our API gateway, right? This is going to be the API for our legacy app. I create this bucket from which our CloudFormation template will be read. That bucket's created, and now I'm just going to package our CloudFormation template, right? So if you do AWS CloudFormation package, you specify a template file, which in this case is template.yml, and then you specify the S3 bucket to put the build.yml file into. Yeah, so I specify the S3 bucket, and I forget to actually put the YML file, so I'm just going to do that again right now. These things happen. Yeah. I've just pushed the build.yml file there, and that's it. So right now it's in the S3 bucket. I can actually deploy my CloudFormation template from this location. Right? And you can actually see that if I just pause there, the name of the S3 bucket that we just created, some random bucket, has been replaced in that build.yml file that you see there. So now that we have the build.yml file, we can just go ahead and deploy this and see if it works. So when we do CloudFormation deploy, we specify a stack name, in this case Unicorn Tracker Provider, because it's a custom resource provider. We specify the template file, and we do two things. We do a parameter override, right? You can see that here. Yeah, I've just paused it. You see, we've done a parameter override so that we can override a variable in the template with the variable of the API that we mentioned before. And after this, we're going to be adding the IAM capability, right? So that it has access. If you don't do this, you will see the dreaded permissions error. So we have to mention that in the CloudFormation deployment as well. Once you do that, the CloudFormation stack is ready to be deployed. If you're the type that enjoys seeing CloudFormation stacks being deployed, like I am, you can open up the browser and see all the events that are happening, of course. And you will see that the Lambda function has been created. There you go. Yeah, so our custom unicorn tracker has been created, all using the custom provider. Yeah, so the provider has been created. So now that we have done that, we have a custom resource provider. We can create a custom resource, again, using CloudFormation. So I just enter into the directory. And in this directory, this is my very simple template.yml that uses a custom resource. As you can see in line number 3, the type is custom resource. I mentioned earlier that you have to have a service token that's either a Lambda function or an SNS topic. We're doing Lambda, so you have a Lambda function mentioned there. And we're going to create a unicorn. We've chosen a completely random name of Werner, complete coincidence, don't know where that came from. And yeah, let's just go ahead and create a custom resource using CloudFormation. Yeah, that's our Lambda function, and that's our unicorn Werner. Yeah. Again, deploying this CloudFormation is very straightforward. All we have to do is just say CloudFormation deploy. We give the stack a name, and this time we can call it Unicorn Tracker Custom Resource. We point to the template file, and that's it. Yeah. So now the CloudFormation stack is going to deploy, and again, you can view that in the console itself. You will see that the Lambda function's been created, and all of the other resources as well. And now we can actually test out the API that's running, and as you can see there, you can see this unicorn named Werner has been added. Right? So just as a quick recap, we basically first created a custom resource provider using CloudFormation, and then we created a custom resource using CloudFormation to add like a unicorn to our legacy app. So we've done that using CloudFormation. Now let's look at how we could potentially do that using Terraform. And for that, I hand the mic over to Martijn.
First, a quick refresher on Terraform, because it works a little bit differently than CloudFormation. CloudFormation is, of course, a service in AWS where you send your templates to, and it will manage your stacks. Where in Terraform, you also write those scripts in a little bit different language, but you use a CLI tool to deploy the resources, and the CLI tool will actually talk to the APIs of of AWS. The state, the stack, will remain local if you store the state file locally. You can also share it centrally with all the tools that are provided. In this case, it doesn't really matter. We just save the file locally. One of the great things of Terraform is that you can also use it for different cloud platforms, for technologies other than AWS, and of course also AWS. Terraform works with providers. So if you just download Terraform, it can't deploy immediately to AWS. You first need to specify which providers you would like to use. And if you select AWS, it will download additional libraries, put it in some hidden directory, and from that moment on, you can define the resources of AWS. For example, this example, where we want to deploy an AWS instance. So that's the type, AWS_instance, almost similar to how we define it in CloudFormation with the colons. And then the next one is web, which is a logical name for this resource. So we can reference that resource in other parts of our template or our project. We also have a list of properties, or Terraform calls them resource attributes. This is basically the configuration of that item. So this EC2 instance will use a specific AMI, instance type, etc. And it will, of course, use the AWS provider. Now we can also embed that CloudFormation template we used before within our Terraform template. So in this example, we translated the YAML example towards JSON. We prefer JSON in this example. And you see a couple of components. So on the top, you see the provider AWS, where we also specified a region. We have one variable, that's the name of the unicorn we are going to create. And there are also two specific resources, which is called data. This is where you can retrieve data from your AWS account. So these are in CloudFormation. You will use functions. In Terraform, you will use the data options. And then the resource is a CloudFormation stack with the name unicorn, with some parameters with the template in there. We also have a thing called Terraform modules. So what you, for example, have in CloudFormation is if you create your template, it suddenly grows towards 1,000 or 2,000 lines of code. Same thing can happen in Terraform, but the great thing in Terraform is you can put it in separate files, but you can also create something called a module to isolate, for example, all your servers in a particular module or a database in a particular module, so that you can easily reuse that across multiple teams. And that's also something we want to do for our unicorn tracker. It's easier to share a module with our colleagues instead of a template that they have to update in their Terraform projects. So this is how it looks. When we create this module, we can share it on a lot of locations. We chose for the S3 an HTTPS endpoint, so that is basically a public endpoint where we can retrieve that module. So let's say we deployed that module to S3, to HTTPS. In our new Terraform project, where we want to leverage the unicorn tracker, that can be basically any application. There we define all our resources, but also invoke the module and configure the module. Plan and apply, and then when you apply this template, it will use CloudFormation to create that custom resource, together with some other resources that were defined in our Terraform project. When we want to use a module, it looks like this. So this is can be a complete project. We have, again, the provider, AWS. We have two data objects to retrieve some information. And then the module, where we have a source. Based on the path of the source, it will either download it from the internet or go to your GitHub repository, or can basically be any location. And then we define a name, again, completely random, Andy. The module, this is exactly the same file as we used before. That's basically because every project in Terraform is automatically a module if you put it in a separate directory. So what we will do in the demo is put the file in a directory, zip it, and upload it to S3 so that we can use that module. And if we want to automate everything, we also want to automate the creation of and sharing that module. So in this template, we will archive the file, so we'll create a zip file based on the source. So the module will be zipped, create an S3 bucket, and upload the zip we created to S3. And here in the top, you also see that together with AWS, we also have a different provider, which is the archive provider. And the output at the bottom of this example is simply the URL where the module can be found. So that's something we will copy and use when we use the module. So this is where we ended the previous demo. Right? We created Werner, and now we want to create, we want to try out first using Terraform and CloudFormation together. The first example in the slides, where we just embed CloudFormation in our template. There it is. So this is the template again, with the variable, the data objects, and the resource, which is the hard-coded CloudFormation in the template. Give it the name unicorn. You have to pass the parameters, and of course specify the template body. Now we'll type Terraform init, and if you type Terraform init, it will download all the modules and also all the providers. Then we hit Terraform apply. It will ask for the variable, the name of the unicorn, confirm that it's okay to deploy this. And after a couple of seconds, it's now deploying the stack in CloudFormation. CloudFormation is triggering the Lambda function, and it will deploy our additional unicorn. So now if we open the API, we see 2 unicorns and the end join. Like I said, we don't want to share a CloudFormation file that they have to embed in their Terraform project. We would like to share a module. So I copy this template. Let's say I'm going to maintain this for all my colleagues. So I will create a module for it. Here you see the module source, and that's just a copy of the file we used in the earlier demo. Same file. Same things in there. The only difference, this is what they also showed already, creating a zip file. Creating an S3 bucket. And then deploy the file, make it public. So now you can use it everywhere. There are no secrets in there. Of course, if you use secrets and a secret API, then you should not put it public, but put it in your own repository. And as the output, the URL of the module. To show you that the file is public, I will just open a browser. I'm a little bit faster than the demo. So copy the URL to the file. And it will provide the download. So I can also download it, just to show you that it's just a file on the internet right now. And then we want to use it in our project. So this is the whole project we now have. It's just, again, the provider, some data, and the module, where we have to specify that URL to our file. and the name, Andy. It's now downloading the module. So together with all the providers, also the module downloaded, it's stored in the project. And if we, in the future, want to update it, we just have to update the Lambda function. We can keep the template the same, but if we want to make a change in the template, we make a new template, upload a new module, ask our developers, hey, you might want to use our new module. Just change the version type of the module, maybe add some additional parameters, some properties or attributes, and then it's updated. Just so that we actually have a third unicorn now from our project. And there it is. And we can, of course, also destroy the template. We implemented also the delete in the CRUD application. So if we destroy the project, it will also delete the stack and also delete all resources related to that stack. Now it's gone. So the final implementation looked like this. So we have a lot of teams working in their preferred way of working. That can be either CloudFormation or Terraform or CDK, or maybe even another framework, as long as it is capable of deploying CloudFormation stacks. Then CloudFormation will create a stack using the custom provider, and if you need other resources. So without the solution, let's say we chose a different path, we probably have 1,000 engineers all thinking, hey, how should I automate my deployment? Oh, I don't know any programming languages, so maybe I should do something in Bash. Somebody else says, okay, I'm going to learn Go so I can create my own provider for Terraform. And somebody else who's using CloudFormation might think, okay, let's use that CloudFormation custom resources. So you get all the different solutions within your organization, and if you want to make some change in your unicorn tracker, you have to tell all your colleagues, hey, there's a change in the unicorn tracker, everybody needs to change it, we'll do it Saturday night, it will completely go wrong, everybody has trouble with rolling back, etc. And with the solution, if you look at this diagram here, if we want to change something in the unicorn, it's basically updating the Lambda function, updating the CloudFormation file, share the CloudFormation file with all the teams that use CloudFormation, share the module with all the teams that use Terraform, and everything is automated and can be tested. And if you use your versioning correctly, it can be rolled out in separate weeks. Few next steps for Sohan.
Yeah, okay. So earlier Martijn took a poll of how many people use CloudFormation and Terraform. Any CDK users here? Anyone? Not as many, right? This is good. As Martijn said, this is a solution that we see that when there are large organizations, teams tend to use their own set of tools, services, etc. Right? So maybe there is another team that uses a different infrastructure as code provider. So how do you integrate that as well? You could potentially also use AWS CDK or Cloud Development Kit. For those of you all not familiar, and maybe I can spend a little more time on CDK because there doesn't seem to be as many users here. CDK is open source. It is infrastructure as code. And again, you can provision and build and deploy resources in the cloud. The difference, though, is you can do that using your favorite programming language. In CloudFormation and in Terraform, you were using a very structured way like YAML or JSON or HCL. But here, you could use TypeScript, JavaScript, Java, Python, Go, and C#, if I'm not mistaken, right? And also, you can do programming things like doing conditionals, for loops, if-else statements, and all of that. So imagine creating cloud infrastructure using your typical programming languages. How CDK works is it's a sort of like a layer above CloudFormation. So you have stacks very similar to CloudFormation stacks, but you also have these things called constructs. So in CDK, there could be 3 levels of a construct. A level 1 construct is a direct mapping to a CloudFormation resource. So for instance, in CloudFormation, if you have CFN bucket as an S3 resource, an L1 construct in CDK directly maps to that. An L2 construct is a curated construct by the AWS team where you have the best practices of an S3 bucket. Yeah? So you don't have to mention every single variable or different things that you want to do about the S3 bucket. If you say new bucket, using the best practices that we have curated for you, it creates that. And in an L3 construct, you can basically use patterns that have already been developed, right? You can create your own, you can share your own, but you could also use existing L3 constructs. So for instance, you could use a pattern for a serverless database with a queue and a Lambda function, and just reference that with 1 line of code, and boom, that whole pattern is created for you. The commands in CDK, again, follow a very similar sort of syntax. When you do something like a CDK init, it initializes and builds a new project. There is a CLI, of course. When you say CDK synth, it synthesizes the templates and assets that you have already defined. And when you say deploy, it deploys it via CloudFormation. Yeah? Very often when I talk to my friends who do a lot of front-end dev work and are familiar with programming, but not necessarily on the cloud side of things, I say, hey, CDK is the place for you, go check it out, so do check it out. You could do this entire thing with custom resources, Terraform providers. You could also use CDK. And just to mention, there is Terraform support in AWS CDK as well. So there is something called CDKTF, another acronym for you, which is Cloud Development Kit for Terraform, right? And using this, you don't need to learn HCL, so you can actually still program in your own programming language and still access the same resources. Typically, we suggest people to use CDKTF if you want a really strong abstraction layer here, or if you just prefer programming it in like a programming language of your choice. So as we've seen in this demo, you could use CDK, you could use Terraform, you could use custom resources, and with this sort of implementation, you could still achieve what the customers that Martijn was speaking about really achieved. For next steps and resources, and maybe you want to take a screenshot of this, all of the code that you saw on the slides and in the demo is available on github.com/tfworks. Again, shout out to Dennis and also a couple of other people, Anton and Srinivas, for helping us with this session. Do read a little more on custom resources if you haven't used it already. Again, I think that there is a lot of power in being able to do it, and especially if you're working with third-party resources that you want to automate using CloudFormation. And also, do check out Terraform provider, and that's the link right there. Before we end, like a quick wrap-up and summary, and also a bit of a disclaimer. So, as a summary, we started out with what custom resources were and how a custom resource needs a custom provider, and you could do that in CloudFormation. We spoke about Terraform and Terraform providers and then integrating the two. And as next steps, we spoke about doing the same thing with CDK as well. Now, this has been proven to work with both legacy and modern applications at scale, but we're not saying this is the only way for you to do this, right? This is a way to solve a problem. My favorite answer to anything in technology is it depends, right? It really depends on your SLAs, on your team, on your dependencies, on your tech stack. So this could be one approach, but like I said, it's worked at scale for a legacy app and for modern applications as well. So, you could expect results with it. Just want to say thank you again. Hope you have a good rest to reInvent. Martijn and some of the team will be here for questions. As luck would have it, my next session is 1 hour from now, so I have to power walk to the win. But they will be there for questions. Thanks again, and see you soon.